Hey everyone! In this video we'll cover the official Apache Kafka Introduction, what event streaming is, what Kafka is, and how it works. First, what is event streaming? The docs say event streaming is like the central nervous system of the digital world. It's the foundation for an always-on world where more and more business is software-defined and automated. Technically, event streaming means capturing data in real time from sources like databases, sensors, mobile devices, and apps, as streams of events. Then you store those streams durably, process and react to them in real time or later, and route them to different systems. So the right information is in the right place at the right time. What can you use event streaming for? Lots of things. Processing payments and financial transactions in real time. Think stock exchanges, banks, insurance. Tracking cars, trucks, fleets, and shipments in real time in logistics and automotive. Capturing and analyzing sensor data from IoT devices, factories, wind parks. Reacting to customer interactions and orders in retail, travel, and mobile apps. In healthcare, monitoring patients and predicting changes so you can act in emergencies. Or connecting and sharing data across different parts of a company. And it's the backbone of data platforms, event-driven architectures, and microservices. So what is Apache Kafka? Kafka is an event streaming platform. It gives you three main capabilities in one system. 1. Publish and subscribe to streams of events, that's writing and reading, including continuous import and export from other systems. 2. Store streams of events durably and reliably for as long as you need. 3. Process streams as they happen or later. All of this is distributed, scalable, elastic, fault-tolerant, and secure. You can run Kafka on bare metal, virtual machines, or containers, on-prem or in the cloud. And you can either run it yourself or use a fully managed Kafka service from various vendors. How does Kafka work at a high level? Kafka is a distributed system of servers and clients talking over a high-performance TCP network. On the server side, you run a cluster of one or more servers, possibly across multiple data centers or regions. Some servers are the storage layer, those are the brokers. Others run Kafka Connect to continuously import and export data and integrate Kafka with databases and other systems. The cluster is built to scale and tolerate failures. If a server goes down, others take over so you keep running without losing data. On the client side, you build applications and microservices that read, write, and process event streams in parallel, at scale, and in a fault-tolerant way. Kafka ships with clients built in, and the community adds many more, for Java, Scala, Go, Python, C, and others, plus REST APIs. Now the main concepts. An event is a record that something happened. In the docs it's also called a record or message. In Kafka you always read and write data as events. An event has a key, a value, a timestamp, and optional metadata. Example: key Alice, value made a payment of $200 to Bob, and a timestamp. Producers are apps that publish, write, events to Kafka. Consumers subscribe to and process those events. Producers and consumers are fully decoupled. Producers don't wait for consumers, that's part of why Kafka scales so well. Kafka also gives you strong guarantees, including exactly once processing. Events live in topics. Think of a topic like a folder, events are like the files in it. For example, a topic named payments. A topic can have many producers and many consumers. Events aren't removed when read, you can read them as many times as you need. You can figure how long Kafka keeps events per topic. After that, old events are discarded. Because performance stays stable with data size, keeping data a long time is fine. Topics are partitioned, each topic is split into buckets spread across brokers. That lets many clients read and write at the same time. When you publish an event, it's appended to one partition. Events with the same key go to the same partition, and Kafka guarantees that consumers read a partition's events in the same order they were written. For fault tolerance and availability, topics can be replicated even across regions. A typical production setting is a replication factor of 3, so you have 3 copies of the data. Kafka also has 5 core APIs, plus CLI tools for admin. The admin API, manage and inspect topics, brokers, and other Kafka objects. The producer API, publish streams of events to one or more topics. The consumer API, subscribe to topics and process the streams. The Kafka Streams API, build stream processing apps and microservices, transformations, aggregations, joins, windowing, and more. It reads from topics and writes to topics. The Kafka Connect API, build and run connectors that import and export data between Kafka and external systems. In practice, you often use existing connectors from the community instead of writing your own. Where to go from here? Do the official Quickstart for hands-on Kafka. Read the full documentation for more detail, and check out Kafka books and papers if you want to go deeper. Look at real use cases on the Kafka site to see how others use it. And join a local Kafka meetup or watch talks from Kafka Summit. That's the introduction to Kafka from the official docs. If this helped, like and subscribe, and I'll see you in the next one.